Hello everyone, Nook Games here with another video of the tutorial series of remaking the core version of Getaway Shootout. In the last video, we implemented game state into the game, so now players, when they finish, they'll increase their score. And the score is running behind the scenes, there's currently no visual for it. But once the score reaches a max score, that player then wins the game, and then currently the game is just over, but in the future it'd be a game over screen that the player can then replay. In this video, we're going to be continuing the game state, and we're going to be adding another data point in the game state, and that's going to be the player finish order. So in the original game, the order for the start of the next round of the players depends on the order or the finish order of the players in the previous round. So players that were closer to the finish or finished would start at the back of the starting players, and players that were really far behind will start at the front of the players. So in order to have this system work, we just have to set up a way of determining how close a player is to the finish, and then using that data to notify the game state to order the players based on that metric of how close they're to the finish. So let's get into it. The first thing I'll do is jump into the game state and start working on implementing the player order. So I'm going to go back to the script that we made in the last video, and if you remember, this is just a class that's going to hold all of our unique state variables of the game, anything that we want to keep track of between multiple scene loads. So player score was 1, and I'll create another one here, and I'm going to do an int array, and it's going to be called player order. And this will be the order of the players, which each integer in this array is going to be the player ID. And when we initialize it, instead of initializing it to all zeros, because that'd be the order would be all players 0, which is what we don't want. We want to just have some sort of order at the start that includes all the players. And what I do in the original game is just a simple increase 0, 1, 2, 3 for the player order to start. So that's what I'll do right now. And if we set player order I to equal I, that should work. But before we do that, we'll have to initialize it to an empty array of the number of players before we start accessing it. And reminds me, I did see an email once suggesting that the player order could be random even at the start, because every time you play a new game, the player order is the same. So you could definitely do some sort of randomness here to just even at the start have some sort of random order. But I'll leave that how it is right now, and I'll save that. Now the other thing I want to do is to access this player order. Right now it's private, so I'm actually going to make this public for now, and in the future we could make accessor methods, but I think having it public is going to be fine. And that's, I'm making it public because now that's what I want to use in Game Manager. And basically when we create players, instead of looping through just 0, 1, 2, 3, 4, or 1, 2, 3, we want to use that order to now loop through the array based on the player index in that order. So I'll keep this outer loop the same, but I'll create a variable up here. I'll call it player ID. And this is going to simply be state player order and I. So now this is the actual player ID that we're creating, and everywhere where we're doing previously the I variable, replace it with player ID. So now we're only using I to get the player ID, but I'll keep this reference to the I variable because this is actually the variable we use for the spawn position. 0 being we want to spawn the player at the back, and the max spawning the player in the front. And currently we spawn all the players at the exact same spawn point, but I'll change that here. So spawn position, we're going to actually increase for players later in the order. So if I do something like this, plus equals new vector 2, and actually I could do vector 2 dot right, or I thought I could do, vector 2 dot right, like that. So this would increase the spawn position by 1, but I want to increase it by maybe about 0.25 units, but importantly, multiply that by each player's outer index with something like I. Okay, save that. Now the players should be spawning not at the exact same location, but slightly offset, and it should be dependent on the player order. So it looked like they spawned pretty similar right when I press play. I'm going to actually increase this a little bit, maybe go 0.5. And now try if it increases. Okay, that still looked a little close. I'll increase it just a little bit more. Basically so we can actually see that there is a gap between the players on start. Okay, there we go. So the players are now starting separate, and it should be on the order that we specify. Now, one thing I'll do right now, because it is a little confusing to know what our player is since we don't have player sprites in the game right now. It's all the same character. So I'm just going to go to here and make the computer players a different color. And since each computer player is adding a component, this player computer controller, I'm going to do it there just temporarily. So if I go to here, all I want to do is just change the sprite colors on awake for the computer. This won't change their ragdoll, but I think it'll be fine just for debugging. So for each, and I'll do sprite render. So I'm just getting all the sprite renderers on this player object, and then I'm just setting the color, and I'll do something like color.green for right now, and I'll make a note just to remove this in the future. Okay, so now it'll be easier to tell what player is ours because the other ones are now spawning as green, which looks good. So importantly, when a player dies, since their ragdoll is a whole new object, they won't keep the color, but it should be fine for how our game, just for testing purposes. Okay, so now we have player order working. We set it to a constant 0, 1, 2, 3 of just a linear order. The next thing to do is to actually get the finish order when one player finishes, so then we can use it in the next round. And as I said at the beginning of the video, we're doing this order based on the distance to the end. So I'm going to jump to the waypoint manager. And this is where we want to calculate each player's distance to the end, so we can then use it as a metric for ordering the players. And this will actually be useful if you implement the top nav bar showing each player's position as they progress to the map, like in the original game. So yeah, it'll turn out useful. Okay, the first thing I'll do is create a float on this navigator info, and I'll call this distance to finish. And this will just be updated every frame on how close that player is to the finish. And the way I'm going to do this is basically first make an array here, something called waypoint dist. And this array is going to be an array of floats corresponding to every waypoint, which is the waypoint's distance to the end. So waypoints that are very close to the end will have a small distance, obviously, and some of the start waypoints will have large waypoint, and this will all be calculated at the start. So when we have an awake function right here, we get all the waypoints. This is where we want to do the calculation of calculating all the distances. And the way I'm going to do this is actually going to be a reverse for loop. So right now it actually auto implemented the just normal for loop. I want to actually go through the array in the reverse order because that's how we're going to be calculating distances to the end. So we'll start at the last waypoint, and while I is greater than or equal to 0, and decrease I. So that's going to be the reverse for loop, looping at the last waypoint, and we'll have to keep a running total of the distance. So do something like this. And all we want to do is to set waypoint distance dot I to be equal to the distance. And basically we want to increase the distance by some amount. And that's basically going to be the amount compared to the two waypoints. The first thing though I'm noticing, we should initialize this waypoint array to just the new array of size of the waypoints so we don't go out of bounds. The next thing I want to do is to, well, so the last waypoint is going to have a distance of 0, obviously, but all the other ones are going to be calculated by the distance to the waypoint above it. So actually I'll do it maybe up here, is to calculate, I'll call it D for short, for distance, and this is just going to be waypoint distance I plus 1 minus waypoint, or not waypoint distance, waypoint I plus 1 for waypoints, that position, position minus our current waypoint or waypoint I, and minus that transformed up position. And basically we want to get the distance between these two waypoints. Before we do that, actually I'll convert it into a vector 2 so we don't worry about the z component in case we accidentally set the z component. And Unity has a nice little attribute to vectors. We can get the magnitude, which is the distance. So I'll do that. So basically we get the magnitude of this difference between the next waypoint and our waypoint. So that will be the distance. And actually, instead of storing as temporary variable, we can do something like this. Distance plus equals. And we set that there. The last thing we need to do is actually just to modify this function a little bit, because this will give us an out of bounds if we start with the last waypoint. So we actually want to start with the second to last waypoint. And this should work because we don't have to modify the last waypoint since it's obviously going to be 0 since it's the finish position. Okay, so now we have this nice array of the distance from each waypoint. And I'm creating this because it's better just to do this at the start instead of doing this every frame of the update of calculating the distance all the way till the end. And we'll do that. We'll use this array now in the update loop. And we have an update navs method. So I think this is where I'll put this update waypoint distance, or maybe I'll make a separate method. I'll just put it in here for right now. So at this point, we have updated our current waypoint, and we're looping through each navigator. The last thing to do then when we have a new waypoint is to calculate our current distance to the finish. And all we have to do is to, one, get the distance between the navigator, which is the player, and to that waypoint. And then we can use that array that we just created to get the rest of the distance. So I'm going to say waypoint. And that's going to be something very similar to this, where we're getting a difference between two positions. So if I do something like, so we have our current waypoint here. And actually, so this, it could potentially be updated, and that's actually in the nav.value, that current waypoint. So I'll access the current waypoint that way. So waypoints dot current waypoint. And again, we'll do something like transform.position. I'll also convert this into vector2 just to prevent the z component from affecting distance. And now I'll make this difference between that waypoint in the player's position, which is just nav. Since this nav is a dictionary, the key again is the transform. So if I do nav.key, that's the transform, and then I can do position like that. And I'll also convert this into a vector2. And again, like the previous, we just want the magnitude. So doing something like magnitude there should work. So now we got the distance from the player to the pretty much closest waypoint or the next waypoint. The next thing that we want to do is to then use that distance plus the distance of the pre-computed waypoint distances to get the total distance. So float total distance equals the distance to the waypoint plus accessing this array, so that new array that we just created, waypoint distance of that current waypoint. So distance to the waypoint plus the waypoint's distance to the end will give us the total distance. And instead of actually storing this in a temporary variable, we can store it just here, nav.value dot distance to finish equals that. And so I think this method would work. One thing I'm thinking through now is at the very start, we should start all the navigators at the maximum distance because they're starting at the start. So I'm just going to do that here. When we add a new player, I'll do something like, so we'll get the value that we just added by here. Or actually it's a void, okay, so Maybe I'll do something like this. Just keep a reference to that navigator info. Oops. Basically, so I'm creating a reference because before I set it, that way I can easily edit it. And I'm going to say distance to finish. So I'm initializing it to be the maximum value, which is going to be waypoint distance of the first waypoint. So the first waypoint will have the maximum distance. And then now I'll set the navigator info to this new navigator info object that we created. And I could have done that in the constructor. Basically, if I create a constructor here that had a distance to finish, that would work as well. But I think it's fine just to have it like this for now. So I'll save that. And currently we don't have any methods to access now this new attribute we added to each navigator. So maybe that's going to be the next thing that we do. Basically, we want to have a method that maybe gets the current distance to the end for each player. But since actually we're not going to be really using that, all we really care about is the order of the players. So actually, I'm going to do something down here. Public transform. And this could be an array of transforms. And importantly, this is going to be get nav order. Maybe something get nav distance order. Basically, this is going to be an array that is ordered by each navigator's distance to the finish. And we could do this line by line by just writing the code to create an array of the size and then doing the logic of sorting this array. But I'm actually going to be using C#, the link library, to actually use this to make this a simple one-liner. So if I do something like navigator info, and if I do order by, so this is using the link library, and I think this will actually increase the size of our game, and perhaps it'll be a little slower, but for this video, it'll make it a lot easier to implement. So if I do order by, and then if I do something like pair, so this is each pair in that dictionary, and if I do order by the pairs value dot distance to finish, and importantly, we don't want to return the actual dictionary pair. We want to return the dictionary's key, which is the transform. So then I'll use another link method, which is called select, which will just select the pair's transform key, something like that. And then at the end, I'll make it an array to convert it to a transform array like that. Okay, so I'll save that. And yeah, if you didn't really follow along there, it's fine, because we'll only be really using this once. And you could do it manually by actually just writing the code to create an array, ordering it yourself, but this is just a nice quick way to get something implemented. So now if I jump to the game manager, we can actually use this new method that we created, the distance order. And where would we like to use it? Well, we'd like to use it right at the end when the round is over. We want to know what the player order should be for the next round. So if I go to round over, and if I do something down here, let's see. So we call state.roundover. If instead, if I jump to game state, one second, game state over here. If I jump to this round over function, we could actually create a new variable, call it int array, and maybe we call it player order. So we can just set player order, which is our one on this game state, to equal player order. So something like that. And it really doesn't make sense. I mean, this logic actually could be done just by doing it on Game Manager, since it's a public array, but maybe in the future it's better to make this private and have accessor methods. But I think this will be fine to have something like this for right now. So I'm going to save that, and then now jumping back to Game Manager, we have to specify the player order. So I'm going to create a new method, or not void, but int, and it's going to be called get player order. And this will allow us to get the player order from that waypoint manager that we have a reference to up here. So waypoint manager dot get nav distance order. So importantly, this could be an array of transforms. So I'll do something like this, transform. And basically we want to convert this into an array of integers, which could be each player ID. So we could actually use that link library to do almost another one-liner here. I'll just for here, I'll do it actually manually. I'll do something like int array IDs, and then equals the same size of the array that we just got. And basically all we have to do is just loop through the array and set each IDs to be navigator, and we have to get the I navigator, and then get component player, the player script, because each navigator will have this player script that we have attached to all of those players. And earlier we have made a nice function in that player script to get the player ID, which is just the index that we're looking for. And then finally just return the IDs. So right here inside this function, we'll pass in the player order, which is the finish order that we're looking for. Now, I gotta think now. So will this actually be the opposite of what we want? Basically, it's good to do order by the distance value. So ideally, we want distances with the smallest value to be first. I'm just gonna click play and we'll see what happens. So we start in the back because that's how we start each new game. But if I finish, hopefully we should start, well, I guess we'll start in the back again. That wasn't that helpful to know, but it seemed like that worked, at least in that case. We'll have someone else finish, a computer player this time. Okay, so computer players finished. And we were at the back there that time. We were in last place. Now we're in first place starting. And assuming whoever finished, since all the computers are green, it's hard to tell. But whoever finished then finished, or it now starts in the last. Okay, that seems to be working good. And that's basically all that was implemented in the original game. There is one small note though. So basically we're using these waypoints to calculate the distance, and depending how the player ends, perhaps if the finish object's a little far from the distance, you could get a scenario where a player who hasn't finished is actually closest to the last waypoint than a player who's finished. So it would be important to prioritize players' finish first. So if I jump to the game state, so on round over, we input again our player order that we got from the game manager, but we also have this finished players list, and we would want to make sure that this list is the start. So if player 2 finished first, we would want to make sure player 2 is the first one in the player order, and manually set that. We could do it here. So with this player order array, we could swap some things around. But I might just actually leave this for right now. It is working pretty good. I mean, it is an edge case for this player order not to be the order that we want. Like when a different player that hasn't finished actually is in front of the order compared to someone's finished. But I think I'll actually leave that now, and perhaps later or behind the scenes in the videos, I'll implement that function of making sure finished players are first in the order, then the rest of the unfinished players go next. But I think this will be a good place to stop. And at this point, we pretty much have all the variables that we need to keep track of game state. Player score and player order are the ones that I used in Getaway Shootout. You could add more things to your game state in the future, maybe like the current round that you're at, the characters that you're using could be part of the game state, and so forth, anything that you want to keep between rounds. But yeah, so in the next video, we'll be actually now kind of wrapping up this whole the game logic, I'll call it, and that will be having the game switch maps. Because right now, every time a player finishes, we have the same map, just always by default instantiated in the game. So we'll create kind of just a simple little map manager that will navigate between the next maps and so forth. So that'll be the next video. Thank you for watching, and see you next time. Thanks.